In this video, we'll take a look at some advanced options in the limit editor, as well as the parameters tab. We're in the same sequence that we've been running, but now when we open up the limits editor, we'll enable advanced view. This brings up a couple new options. The first that we'll look at is using memoryless items instead of user-defined for our limits. For curves, we can choose either single values or curves to use from the memory list. Whatever we pick will be reflected in the dropdown. We can also choose between using the X, Y, or Z data for these limits. I've created a couple curves that have been saved to disk and then recalled with the names upper and lower, so I'll pick those and enter them for our limits. I run the sequence, my limits get recalled from disk, it calculates them in the limit step, and then the step passes. If I open up this step, it will now read and show me the curves. This method can be really useful. You don't even have to be recalling from disk, you could be calculating the curves from within the SoundCheck sequence itself. In the previous video, we looked at offsetting the Y data. When we have advanced view enabled, we can shift the x-axis either by hertz or by percentage. If I offset it by 20 hertz, you can see on the x-axis, everything is shifted over by 20. If I offset it by -20, it'll go back into place. Now if I offset it by 10%, all of my x values will increase by 10%. Now we're going to jump over to the Parameters tab. Under Limits Parameters, we can set if we're using upper and lower limits, or lower only, or upper only. The other option we can select here is the alignment. What we have been using is absolute. What that means is the exact number that you enter in an upper or lower limit, it will use as your limit. But what it also does is interpolate between the points that we selected and will set limits on those interpolated points. Individual is also absolute, but it does not interpolate. A really easy way to look at this is if I set a limit at 100 Hz and 20 kHz with a Y value of 90 and click apply. With individual points selected, this is going to pass, because what it does is look at 100 Hz, which is about 75, and then looks at 20K, which is about 80. Both of those are under 90 dB, so it passes, that's all it cares about. If we go back and switch from individual points to absolute, it's going to interpolate between those 2 points, draw a line, and we're going to fail because one of our points in between those was over 90. Floating data and floating limits are very similar. These always force you to use both upper and lower limits. Even if I had upper selected before, the second I switch to floating, it's going to force me to use upper and lower. The reason for this is when we select floating, really all we care about is the difference between the two values, the upper and the lower. I'll plug in some values for my upper limit, and then for my lower limit, I'll plug in the same x points, but just put 0 for the y points. When I click apply, it's going to float my limits and do its best to fit around my data. That means that the differences between the y values will stay the same, 3, 10, and 5, but the absolute values will change. It moved these two curves up to where my data is and attempted to best fit them. This setting would be used if you cared about the shape of your frequency response, but weren't trying to set limits on the absolute level. I'm going to revert this step just to clear out any changes I had and switch from floating limits to floating data, and I'll plug in some similar numbers. The difference between floating limits and floating data is that in floating limits, the limits will change to best fit around the data. With floating data, the opposite's true. Instead of moving the limits around, we're actually going to change what the value of the data is. Now when I click apply, you can see that the limit steps stay the same, but the y values of my fundamental have actually changed to try and best fit around my limit curves. Again, I'm just going to revert my step to go back how it was. The last type of limit step is aligned either limits or data. This one's a little bit unique. Once I select align data or limits, you can see under the x and the y axes, we can specify an alignment reference. What this step is actually going to do is output a new curve at this reference. It will take either your data or your limits and align them, in this case, to 0 dB at 1 kHz. In this case, I don't particularly care what my limits are, so I'm just going to put some numbers in there as placeholders. I run my sequence, my step fails, but what I care about is this fundamental align curve. When we open this up, you can see I get a curve at 0 dB at 1K. If I open up a table, it's a really easy way to see this. 1K equals 0. I'm going to set us back to absolute limits, change it to lower only, and take a look at what happens when we output a failed curve. I'll make our limits here between 1K and 20K from 80 to 85. The step fails. But what this is going to tell us is which data is below the limit and which data is above the limit. If we look at the memory list, we can see it output frequency response upper limit failed points and lower limit failed points. If nothing failed, or you don't actually have an upper limit, that curve is just going to be NAN. What we're interested in is the lower limit failed points. One thing to keep in mind though is if you view this on an XY graph, it's actually not extremely helpful. Since the points interpolate, it can be a little tricky to see exactly what failed. So what I'd recommend is to open it up on a table. Now when I look at this at a table, I can see there are 7 X points, and then it gives me the Y values. This is every point on my original curve that failed my limit. I'm going to drop in the original curve next to it in the table. This is a really convenient way to see which frequencies failed, instead of just an overall pass or fail. For the next example, let's switch from using a curve to using a single value. We're going to take a limit of the average sensitivity, and for my upper limit, what happens if I type in 89.25? Should this pass or fail? I click apply, and it actually passes. It's rounding up 89.25 to 89.3. Our sensitivity is 89.3, so we're getting a pass. What we want to look at here is this absolute comparison precision. This is how many decimal places we care about when we're taking limits. It's set to 1 now, and if you look at the top of the limit step, it's showing our value as 89.3. But if I increase this absolute precision to 4 decimal places, we can see my average sensitivity is actually 89.2820, compared to 89.2500. Now when I click apply, the step fails. This is something to keep in mind, especially when you're using really small signals, like millivolts. The next thing we want to look at in the Parameters tab is the mapping, linear versus log. For this, I'm going to jump over to a recalled curve I have called log v lin. This curve is 5 dB at 100 Hz to 3 dB at 10K. For my upper limit, I'm going to type in 1K to 2K, both at 4.4. This red line is my upper limit, this blue line is my data curve. I click apply and the step passes. We'll head over to the Parameters tab and switch the mapping from log to linear. Now when I click apply, the step fails. I can see my margin is now -0.4, and my green indicator is showing that the failure point is above my limit, even though the blue curve looks like it's below. To see what this is actually doing, I'll change the x-axis mapping mode of my display from log to linear. You can see here when the x-axis is plotted linearly that this actually is above the limit, so it fails. It's really important to understand what's happening in your limit step, that what you're displaying matches up with what you're mapping. The last option in the limit step is float limits. This is very similar to the floating data or floating limits, except what this will do is actually allow the x-axis to float. If I enable this, it will float the x-axis to fit as best as possible. If you go back to the data screen, you can see that my upper limit actually moved on the x-axis, but leave the y-axis the same. Thanks for watching. If you have any questions, please email us at support@listeninc.com.